Okay, so continuing on the Raoult's law legacy, we have an even more tougher problem to deal with. We're still using the same law. Just so you remember, it is P of whatever you're looking for equals the mole fraction of whatever you're looking for in solution times the vapor pressure of the pure solution of whatever you're looking for. So let's say it was water. To find what the pressure of something dissolved in water is, you would need to know the pure pressure of water at the temperature. Realize that this changes with temperature. Luckily, we haven't dealt with a problem that deals with that yet. Okay, so this is our equation for ideal solutions, which says here, ideal. Okay? Assume that benzene with a vapor pressure of 75 torr and toluene with a vapor pressure of 22 torr form an ideal solution. What is the composition in mole fraction, so we're looking for this, of toluene of a solution that has a vapor pressure of this? So this is the total vapor pressure of both of them. Realize that even though something is dissolved in water, that thing is still being turned into the gas. Like there's still some molecules of gas floating in there. Now it may be a really small pressure, it may not be that very big, but it doesn't matter. Realize we've been dealing with torr here, not ATM, which is a good thing. Only with this equation, the units must matter on both sides. That's all I can say. So we have that. Now, assume that benzene and toluene. So they both put together, their partial pressures here equal to that. So let's go ahead and say that the partial pressure, and let's use B for benzene. Oh, that's a bad B. That's a bad B too. Yeah, that's better, I guess. Plus the partial pressure of toluene, which we'll use as T, equals the total pressure. Okay? So, partial pressures, it's just a basic gas law rule. So we know that. Now, how do we figure out what these two are? Well, we could just use this equation to figure that out, right? So what if we took this and plugged into each one, right? But each one with a different variable, of course. This one is for the benzene. This one is for the toluene, especially. So we'll use the right subscripts. Okay, so this for benzene. So the mole fraction of benzene times the pure pressure, pure vapor pressure, or the standard of benzene. No, that looks like plus. Now we do the same thing for this. The partial pressure of toluene times the standard, or whatever you call this. I really should look that up, what it's called, but vapor pressure of the pure. And that all equals the total pressure. Now, before we start plugging in and trying to figure out which one's which, let's think about something here. We have this number here. We have this number here. So we know what these are. Oh no, can't. We know what this one is, and we know what this one is. We also know what this is from this, since the total is equal to that. But, do we know what this is, or this is? No. We have two variables we don't know, and we're trying to figure out what the mole fraction of toluene is, which, basically, we're solving for this one. That's the one we're solving for. But how can we solve for that if we don't know what this is? We will need another equation to figure out what this is. But how can we figure that out? That's where a math property, you probably have heard this before, but remember that these are mole fractions, right? So wouldn't that mean that all the mole fractions added up will equal 1? So and that's a basic rule of fractions, of parts of a whole, I should say. Like, this is parts of a whole. So if we added these two together, it would make 1. So we would have x of b, the mole fraction of the benzene plus the, no, why did I do a giant B? Plus the mole fraction of toluene would equal 1. Now we can just manipulate this equation to solve for K of B. So, or not KB, mole fraction of benzene would equal 1 minus the mole fraction of toluene. So, since we have this, now we can just take that and plug it in to this one. Alright? So, now, what this new equation would look like is this. 1 minus the mole fraction of toluene times the partial pressure of benzene, because remember, this and this are exactly the same, so it would work, plus the mole fraction of toluene times the vapor pressure of pure toluene, and that would all equal the total pressure. Okay? So now we can literally just plug and solve for this variable. Okay? So, now I'm just going to use this color. This is equivalent, the pressure of pure benzene is 75 torr. So we have 75 times 1 minus okay. So 75 times 1 minus partial pressure of toluene plus, now what's the pressure of pure toluene? 22, which equals 36.5. That's what we're trying to get. Okay? So let's go ahead and solve this, shall we? So 75, so we have 75 minus 75, I just distributed here, x of t plus 22 x of t equals 36.5. Okay, now we just subtract 75 from both sides and combine like terms. So 22 minus 75, that's negative 53, so negative 53 times the partial pressure of that equals, okay, so 36.5 minus 75, negative 38. 38.5. Now we divide both sides by 53. So now we get that the partial pressure of toluene, and this is in solution, which is a good thing because we're trying to figure out a solution here. We're not trying to figure out, like the blast problem, what it is, what the mole fraction is of the vapor pressure. We're just trying to figure out in solution. So that would equal, alright, so Divide that by 53 and make that negative. Equals 0.726. 0.726. Which is pretty darn big considering that toluene. Well, it's really hard to tell which one's being dissolved in which, I should say. It's basically whichever one's in the greater amount. So from what it looks like, toluene is the solvent, and this is the solute. Okay? But yeah, that's what our answer is. Now, if it asks what the mole fraction of toluene is in the air, or in the vapor pressure above the solution, we would take this, plug it into this. We would also figure out what the mole fraction of benzene is, plug that in to figure out what the partial pressure of that is, to figure out its mole fraction in the air. But yeah, they could totally just do that either way. But yeah, this was a pretty interesting problem.